Hi students, today's lesson will be on solving using the quadratic formula. So yesterday we focused on learning that the discriminant is the b squared minus 4ac part of the quadratic formula. And there's lots of things we can learn about the discriminant in terms of what it tells us about the roots that we have. So just wanted to highlight today's announcement first. Today, if you have not completed the discriminant activity from yesterday on 10/20, please go ahead and take care of that. Your test will be Tuesday, October 27th, so that will be next Tuesday. So we are finishing up with this lesson today for the unit, and we will be doing more practice and preparation Thursday and Friday, reviewing Monday, and testing Tuesday. So if you are behind on your assignments, please catch up. They go back to last Thursday, the 15th, which was the start of the last part of Module 2. So today, your assignment is to go to Delta Math and watch this video that I'm recording now. And the assignment is called 10-21-20, Solving Using the Quadratic Formula. You are to take notes in the video, which really will be me working out half of the Delta Math problems. There are 14 problems in the assignment, and I'll be working out every other one. I have it arranged so that number 1 is similar to number 2, number 3 is similar to number 4, etc. What else? So I do have a worksheet linked here, and you will need to submit a picture, whether you do it in your notebook or you do it on the worksheet. If you're able to print, then you need to submit a picture of it by clicking on this link. And then, of course, we have Zoom for class. I am not too proud to beg for you all to please join us. Miss Allen meets at 10:25 and Miss Robinson at 1:40, and Miss Klein-Pierce according to her schedule. So right here, by the way, is the worksheet that I will be using, and it has all of the problems from Delta Math typed on it. I did include on page 1 the same handout as yesterday because this is our reference sheet, but today we're going to be using these steps, solving using the quadratic formula from this reference sheet. Yesterday in the video, we did steps 1, 2, and 3 up to finding the discriminant. Today we're going to take that discriminant and substitute all values into this quadratic formula and simplify. So this is the worksheet that I'm getting ready to put under the document camera and work out. Again, I have the formula up here. The discriminant is your b squared minus 4ac. And you're just going to substitute and simplify. I'll be working out 7 of the problems in the video, and your job is to complete the remaining problems. All right. So when we solve using the quadratic formula, it requires us to remember, first of all, that our discriminant is the b squared minus 4ac, which is under the radical. So normally, if you refer back to the handout from yesterday, kind of zoom in here, it says for ax squared plus bx plus c is equal to 0, x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But for all intent and purposes here, for b squared minus ac, we're just substituting out discriminant because that is what the discriminant is. It's the b squared minus 4ac part. So I'm going to teach you a quick song. If we were in school, we would be singing this song in class a lot. And I am not a singer, so I will first apologize. Do not sing at all. But if it has a catchy little tune. And if you learn it, then as you're plugging it in, it'll help you maybe sing the song in your head and memorize it, so that way it becomes a lot easier, okay? And it kind of goes to this. I'm not sure if y'all have ever heard of the tune Pop Goes the Weasel, but the way I sing it goes like this. X equals opposite b plus or minus the square root of the discriminant all over 2 times a. So again, x equals opposite b plus or minus the square root of the discriminant all over 2 times a. Or you can say 2a. Just remember that 2a means 2 times a. X equals opposite b plus or minus the square root of the discriminant all over 2a. X equals opposite b plus or minus the square root of the discriminant all over 2a. So maybe that tune, as I'm going through it, I'll kind of use it. I'll sing it. Y'all just forgive me for my singing. But when we substitute into this formula, it'll actually, we then simplify it. So we already did steps 1, 2, and 3 of the discriminant, of using the quadratic formula, which began with finding the discriminant. So just to review and recap those steps, again, if you have this printout here or you saved it, I asked y'all to at least save it. Step 1 was to make sure the equation was set equal to 0. So if it was not set equal to 0, such as this, you had to set it equal to 0. And remember, you want to move all terms to the side so that our quadratic term is positive. It's always easiest to do quadratic formula if our quadratic term is positive. And because I can't combine the negative 15 with anything when I rewrote it, it was this, x squared minus 6x minus 15 equals 0. So just to recap there. So we first set it equal to 0, then we identify our a, b, and c, then we find the discriminant. So this is going to look familiar to yesterday. So then, once we have our discriminant, we're going to substitute the b value, then the discriminant, then a into the formula. So we're going to plug these three things in, b, the discriminant, and a. Just right here, b, the discriminant, and our a. And then we're going to just simplify it. And we'll have our solution. And I'm going to practice making sure you understand how to type those into Delta Math as well. So recall from yesterday also that solving by factoring works great if our solutions are rational, but it only works if the quadratic trinomial is factorable. Square root property, when we see problems that look like this, where we either have x squared equals a number or maybe a quantity squared in it, parentheses squared, that's when we want to use square root property. The quadratic formula will work for every single type of quadratic function, but it is not like what I put right here. It's not always the easiest, and it can require great attention to detail. So we want to be precise with our steps. We've made it easy by first finding the discriminant. Most students, that's where they mess up, is trying to simplify because they don't take care of the discriminant first. So, but understand that the quadratic formula will work for every type of solving quadratics, okay? It's just not always the most fun or the most efficient. So, first of all, quadratic formula requires it to be in the form ax squared plus bx plus c equals 0. So, first and foremost, it has to be in that form in order to work. So, let's go ahead and do all these steps here and get in the discriminant. Like I said, we're going to do all the odd ones. So, here, it's already set equal to 0, so step 1 is done. Now, I'm simply going to identify my a, b, and c like we did before. So, here, my a is 6, my b is the negative 11. The sign does belong to the number after it. And c is negative 2. If you incorrectly identify these values and use a positive instead because you missed the negative, all the work will be wrong. So it's very important to be very precise in all this. Make sure you identify the correct values. So now we're going to find our discriminant. So 6 squared minus 4 times our a value. I did that wrong. It was b squared. My bad. B squared, so negative 11 squared minus 4 times the a value of 6 times the c value of negative 2. And then we're going to type it in our calculator, whether we use this type of calculator or the Calculate 84 app on our phones. Just do not use like your iPhone one, because how you type in negative numbers and square it and all, it doesn't work quite the same. Oops, so I told y'all yesterday, make sure you put parentheses around everything that you substitute. It'll just help you not worry about, well, when am I supposed to use parentheses? Just use it every time you substitute. So I get a value of 169. So some of y'all might recognize that that's a perfect square. I can take the square root of that. So now we're going to substitute into our quadratic formula. So again, our formula is x equals opposite b plus or minus the square root of the discriminant all over 2 times a. So in this box, I want you to come over here and write x equals. Now remember what opposite means. The opposite of a positive is a negative. The opposite of a negative is a positive. So the opposite of my b value, if my b is negative 11, the opposite is positive 11. And if you look over here, you can think of it as negative, and if I were to substitute negative 11, right? So if I did negative 11, that would end up being positive 11. So just think opposite of b. So I'm just going to come up here and put opposite of b. Oops, sorry. It's a weird looking b, kind of looks like a 6. All right. So x equals opposite b plus or minus the square root of the discriminant all over 2 times a. All right, so 2 times the a coming from here where I wrote down 6, 6 being the a in my ax squared. Okay, so now I just come over here and simplify. So first thing I would do is with this number, see if you can take the square root of it. So can you take the square root of 169? Yes, in fact, it's a perfect square. All over 2 times a, so 2 times 6 was 12. So this means we have two possible solutions. We have one of 11 plus 13 over 12 and one of 11 minus 13 over 12. So that's what that plus minus means. It could be 11 plus 13 over 12 or 11 minus 13 over 12. So you write them separate and then just come over here and simplify. Well, 11 plus 13 is 24 divided by 12 equals 2. That's one of my solutions. Now, 11 minus 13 is negative 2 over 12. If I just wanted to recap that you can simplify fractions in your calculator, negative 2 divided by 12, and then hit math, enter, enter. And we get negative 1/6. So my two solutions, I'm going to come up here and put them in curly brackets, is 2 and negative 1/6. Now, if you think about it, these are rational solutions, right? So if these were rational, if I get rational solutions, it means I could have factored to start with. So sometimes it's easier to just go, can I factor? And maybe try factoring, and then if factoring doesn't work, then use quadratic formula. So I've got my two answers. I'm going to go into Delta Math and type in 2 and negative 1/6. So problem 1. So I have two solutions. Oh, look, and these first ones are multiple choice. 2 and negative 1/6. You will have 2 attempts on getting these correct. Notice here in your solution here, quadratic formula, they have it all written out, the b squared minus 4ac. It's just our shorthand is to put discriminant in there and find it first. But you can see they're doing the exact same steps I'm doing, right? They split it up here, simplified, just like I did in the notes. So I recommend pausing the video now and doing problem 2. Make sure you understand it. Because when we get back, when you resume the video to do problem 3, it's going to be a different type of solution, okay? So pause the video now and do number 2. All right, so now we're going to move on to number 3. Number 3, it is not set equal to 0. So remember we practiced this Monday on the review assignment and also yesterday, but we need to get all of our quadratic terms on the same side. So I'm going to move these terms over by doing inverse operations. I can only add 6 to the 12, so I'm going to put that there. This will now eliminate, and we have 2x squared minus 9x plus 18 equals 0. And this is not going to be factorable. So remember our first steps, identify your a, b, and c. So a is 2, b, negative 9, c is 18. Remember at any point if you want to just pause the video and kind of work ahead and then resume the video and see if you did it right, you're welcome to do that. So now discriminant is b squared minus 4ac. So negative 9 squared minus 4 times a times c. I'll be real honest. When I type this in now, I just go ahead and square that number, and I know it's always positive. So I'm going to do 81 minus 4 times 2 times 18. And I get negative 63. Interesting. Remember from yesterday, when we get a negative, we have two imaginary solutions. So now we want to substitute into our formula. X equals opposite b plus or minus the square root of the discriminant all over 2 times a. So now I'm going to come over here and simplify. And the main focus is going to be simplifying this radical. So that's why we practiced that last week with square root property, and why we keep doing this in the videos. But remember, to simplify a radical, first of all, if there's a negative, we need to put I out front. So I'm going to go ahead and put an I out front and make that positive. We'd want to see that in your notes, okay? And then to see if I can simplify the square root of 363, remember we go to y1, type in the radicand, positive radicand by the way, divided by x squared, and we're looking on our table for the last integer ordered pair. So 163, I see 3 and 7, and that's it. Once we get to, below 1, these y values that are point whatever below 1, we can't find any integer order pairs after that. So I'm going to go here, and 3, 7 is the last, and they're always going to be whole numbers. They're always going to be positive. So 3 and 7. So that means that this square root 63 is going to simplify to 3i square root 7. So let me just help you remember that. That if we do, I'm going to write this down so you will remember to do that for your other problems. We go to y equals and type it, excuse me, 63 divided by x squared. Our xy table gives us 3, 7, and our answer will always be x root y. So that's where we get the 3 square root 7. And we just made sure that because it was negative, we put the I in front of the radical. Okay? So this would be all over 2 times a. 2 times 2 is 4. So it looks like we're pretty much done. The only thing I want you to be consistent about checking for is if you can reduce. So let me kind of give you a hint. I'm going to put a heart around everything here on the outside. If there is a common factor, we have to reduce. Say all these numbers, say 4 was a 6. If this was a 6 on the bottom, then we would divide everything by 3. If all of these numbers were even, we would probably reduce using a common factor of 2. So because when we put a heart around it and focus on these 3 numbers, there are no common factors other than 1, then we are through with our problem, and this is our answer. So now I want to go to Delta Math and talk about how do we type in that answer. So I'm going to open this up, go to number 3. Oh, look, we don't have to. Oh, they didn't even simplify it. Well, we're ahead of the game. Technically, those are not, that's exactly what we got there, I square root 63 over 4. So does it start with a positive 9 or a negative 9? Our answer started with a positive. So we're going to choose this one. And we are good to go. Technically, that does need to be simplified. If we can simplify 63, we've got to simplify it. So just know that either one is going to be acceptable in Delta Math, but technically this is the correct, completely simplified version. Okay? All right. So now, if you would, pause the video and complete number 4, and then resume it for number 5. All right, so hopefully you were successful on number 4. If not, then of course you could go back in and look at the answer and write it in. But make sure on your notes, guys, you're following this table. Even if you're doing this in your notebook, when you turn it in, we should kind of see this format from left to right. If you feel like you write large and it's not enough room, just take your notebook paper and turn it sideways, like turn it the long way and then go across, okay? But make sure you have all this from side to side. So I'm going to pick back up with number 5. Remembering step 1 is to set equal to 0, so we have to subtract 2 from both sides. 3x squared minus 7x minus 2, because there are no other like terms to combine the negative 2 with. My a value is 3, b negative 7, and c negative 2. So discriminant next, d equals b squared minus 4ac So now our calculator. So I just go ahead and square that in my head. That's 49, but of course you can use parentheses if you want. So I'm going to do 49 minus 4 times 3 times negative 2, and I get 73. So that's positive, so I know I'm going to have, and it's not a perfect square. Think about what that means. So I'm going to now substitute it into my quadratic formula. X equals opposite b plus or minus the square root of the discriminant all over 2 times a, which is 3. So now come over here and simplify. I wonder if 73 can be simplified. So again, y equals 73 divided by x squared. I'm looking for a last integer ordered pair starting from 0. So I have 1 and 73. Oh, and that's it. So if I get 1 and 73, it means it can't be simplified. So that means my final answer will just be 7 plus or minus the square root of 73 all over 6. So now I can go back to Delta Math. Did I do something wrong here? I typed the problem wrong. Or is that's just not even the right problem. I apologize, guys. I thought that I changed that problem. Let me go back to, hold on. I'm just going to do this. I'm going to go change the problem. It was, technically, but why is it in a different order? All right, I'm just going to make it this, assign this problem, and make sure that is our number 5. So sorry about that, guys. So nothing will have to change on your worksheet. I'm just rearranging it so that this is the answer for number 5. So again, 7 plus or minus square root of 73 over 6. And there we go. Sorry about that. All right, so that takes care of number 5. So if you would like to pause it and go do 6, that will be the last multiple